Here's a quick lesson on a topic called direct and partial variation. It'll come up on some of the homework questions, so just a quick run through. Variation is how one variable varies or changes in while the other is changing. So remember that everything we're talking about recently and for the near future is relations. So just to remind you what a relation is or what relations are. Relations in math involve two variables. Actually, they can involve more than two variables, but for us, we're going to stick with two variables. So it's how two variables interact in relation to each other. Again, my classic example is distance and time. Driving down the highway. How does distance relate to time if I'm driving down the highway? So there's two things we're going to look at in this short lesson. One is direct variation, and if we have a graph, we can tell if something's direct variation simply by looking at whether it passes through the origin or not. If it goes through 0, 0, it's direct variation, and it has to be a straight line. We're only talking about straight lines here, but that's it. There's nothing added or subtracted in the equation form. So if we're now thinking about the equation rather than the graph, the equation would be in the form y equals mx. Is just, y and x are our variables. Remember, m stands for the slope, but so it's just y is equal to the slope times x. And again, we'll talk a bit more about that as it comes up, but there's no plus or minus anything on the end like there is in this part here, which I'll talk about in a second. But notice how this one I've just highlighted has got a plus b on the end. So otherwise, those two equations are exactly the same. So I'll highlight this whole thing. The equation has something added or subtracted to it in the other form. So the other one is partial variation. So direct variation was the first one I talked about. Partial variation is the second one. So if we're talking about the equation, do we have a plus b or plus some number on the end? B won't literally be the letter B, it'll be some number. And as far as the graph goes, partial variation does not pass through the origin. So if it crosses the, let's say, the y-axis anywhere other than at 0, 0, then it's partial variation. So this should be really simple for us to recognize, I'm hoping. The first one's a graph. Does it go through the origin? Here's the origin. Pretty clearly, this graph is not going through the origin. That makes it partial variation. If it had gone through that red dot that I placed on there, then it would be direct variation. If we're looking at an equation, we're looking for, does it have anything after the x? If it's in this form, y equals something x, mx, is there anything after the x? In the first case, there's nothing after the x. That makes it direct variation. In number 3, there is something after the x. It's a minus 5. So we could think of that as adding minus 5 to this equation. It doesn't matter how you think about it. There's something there. That makes it partial variation. And that is it for this lesson.